Welcome to Energy Talks by Elmhurst Energy, your destination for insightful news and discussion on energy assessment, building performance, and EPCs.
Hello everyone, my name's Andrew Parkin and welcome to this special episode of the Energy Talks podcast. In this episode, we join myself, Chris and Ruth as we discuss what measured energy performance is really all about and why it's important to our industry and the future of what we do. I hope you enjoy.
So obviously there were projects under Elmhurst Consultancy that related to measured energy performance. Can you just talk about those projects and how that has influenced the decision to start a competency scheme? That's sort of from a seed to what we are growing now, what you're growing now.
Yeah. I suppose for any competency within Elmhurst, we probably go for a sort of like a stage development, in the fact that if it's going to be a new product or service, then we want to try and adopt that in the first place and understand how that goes to market. You know, what's that customer journey? What's that feels like as a practitioner, and how that should be governed and managed around on the outside. And then perhaps the next step is then you get other people trying to do that on your behalf. So you've done the sort of you've done the proof of concept, then you do the pilot, and then you get to a point where, okay, is this viable to go at scale, at large, you know, that kind of thing. And that is a standard sort of element that we're doing for any competency within you know, even whole life carbon assessment. You know, we've done the same. You know, can we carry out that service? Can we do some verification so we get all the learnings and we can take all the edges off, you know, that don't work right, and get what the process should flow like? Does it require software? Does it require, you know, understand those sort of pinch points? So the first bit for us out of the original SMETAs was then applying that, you know. So that's why we created software that enabled us to put a measured HTC in it, which was our SAP 2012 HTC. And then we did some energy sprung projects, which were a number of sort of London boroughs, and Barnet, Haringey, Hammersmith and Fulham, Sutton. I mean, you know, there are just a handful of them, where we would do a sample set of buildings pre and post, and that went on over like a 3-year period, because you do the pre, then they would go and do the deep retrofit, then we'd have to come back in, you know, the next heating season, and if it missed that one, it was the season later on, and in the middle of that was COVID and things like that. So Energy Sprung was the biggest one, where we got lots of different buildings and we did the pre and the post, and we were able to understand managing, trying to get into those buildings, what doing the survey was like, getting that data out, putting it in an algorithm, getting the results out, and producing sets of results that you could compare and contrast and report back to a client. So what do they want to know? How did they understand what we were trying to communicate to them? That kind of thing. So that gave us all that learning about preparation, you know, preparing, quoting, you know, that, so that we can inform our customers about it. The other one we started was a demonstration project for Airex. So as part of that was eco-free, so they were trying to get their product into SAP. They had the cost, it was over a couple of years, so it was taking their product, having it installed in a number of homes, and monitoring pre and post over the period of time. We just gave them loads of data, and we did that with BTS. So that was with BTS actually, as we were doing the sort of the delivery part of it, and recording all the data and then putting it just back into their algorithm. They did all the sort of like reporting and giving that back to Airex on that one. So that was the Airex demonstration project. So they were the two main sort of drivers. Then we did some before the competency was like teaching people how to do it on smart HTC. You know, so somebody comes to us, we were sort of wrapping it all together, and the next bit was, look, this can work at scale, and we were involved in a couple of working parties. So one of them was the SMETA's technical working group, which was the business process development group. So that was the one that was, we spent all this money on SMETA's. We've got a number of sort of technology providers coming out the back of it. So we've got solutions. Well, how do we apply that? How do we commercialize that? So that led to this whole Eco4 pay for performance, GBS pay for performance element. And the other working group we were sitting on was with the Future Homes Hub, which was the building performance evaluation team. And that was, I'm going to build a home. How do I evaluate that home at the end of it?
Yeah. So that was stepping stones, I suppose, to where we are now.
Yeah.
What tipped over into, so we've got the competency scheme now. What were was it just that there was an overwhelming, it was clear that all these things had led to that needing, you needed some sort of competency framework for members because this is where the sector's going?
Yes. So
how did that all work?
Yeah. So ultimately, we have methods of measuring a HTC, and people therefore then can use that technology and go to site and measure it and use that HTC in lots of different places and in lots of different energy models. How do we know they're doing it right? So that's where we were coming in going, we've got to ensure there is some governance around this. There is some accreditation around this to ensure that practitioners of that, especially because it's in a new area, and we were talking about this in a conversation we just had a little bit earlier on. We talk about the results that we get from this, and we talk about this thing called a confidence interval, about its accuracy and its precision. Every measurement has a confidence interval with it. We don't talk about that, but we do talk about it particularly for this one because it's new and people want to feel confident that what they're getting is the right measure. We need to we're agnostic of any of those technologies, but we want to ensure that if you're going to be someone to practice this, that you are going to be surveilled, you're going to have all audits, you understand what you're producing, and particularly because this is something new, you're going to be able to communicate that to your customers as well. So you're not just carrying out an operation and here's you are, thank you very much. Here you are, and here's what we've done around this, and this is what it means, and this is the output. And therefore, when something like Eco4 pay for performance comes along, we can then say, if they're competent, they're on this list, you know that they can do it right. So government can go, I'm happy that anyone who's on that list meets our requirements. So there's a standard we know that they're going to meet. Yeah.
Really good news story that we're ahead of it all, really, on that.
Well, I think we're taking ownership for ensuring that the marketplace is not, we don't want it gamed. We don't want it to, it's a lot of this, is using public money in some sort of form, particularly in the retrofit. And therefore, if we're going to be using measurement to help enhance and inform our models and makes decisions based on it, then I want to know that it's right.
Yeah. And just a bit on that sort of, I was touching upon this scheme structure and materials because, we've talked a fair bit about smart HTC and sort of in measured, I think it was at different data points, wasn't it? And it was like the RDSAP, smart HTC, and then the calculator. But obviously this goes more broader than that, doesn't it?
Yeah. So a HTC is an inherent part of an energy module calculation for a dwelling, and so it appears in heat loss calculations. It appears in SAP. It appears in energy fit passive house. So it appears in lots of different places because it is the result of heat losses through fabric, infiltration, which is an undesigned sort of heat loss through ventilation, and ventilation losses, a designed ventilation exchange rate. But all we're doing is we're measuring that. So rather than predicting it, we're measuring it, and we're understanding this comes back to, and I'm sure Luke and his team would have talked to you about the performance gap. That's ultimately what you're getting to is by measuring it, you can then determine the performance gap of this dwelling, against its design.
Yeah, because I suppose the theory is that actually when you calculate it, you assume there are some assumptions that you have to make about how it's put together, or I don't know. Whereas if you're actually looking the actual, then you know that, it avoids any of those assumptions, doesn't it, really?
Yeah. So we are doing everything. We're not concerned with how somebody uses the building, as in how the occupant sort of manages it or whatever. This is all about the asset on its own. It's neutral of occupancy and things like that. It is just how that building performs.
Yeah. So we've talked about what what HTC does here, but how do we then measure the performance, or are there any other ways of measuring? Is it all HTC?
So I suppose think of it a bit like a sort of a flow path. If I want to measure the performance of a building, initially I will always try and measure HTC. Because that tells me at headline level the whole heat loss, of a building. I will then, because that HTC is made up of fabric, infiltration and ventilation, if I then measure the ventilation, I'll measure the infiltration, I can then determine the proportions of that heat loss is being done. How much is it fabric, how much is infiltration, and how much are they difference against the design, and therefore that gives me an idea that where it might be happening. So if I measure something and I've got a difference, I can go, right, I'm now going to measure the air permeability of my home with either a blower door or a pulse, and that will give me an infiltration, and I can put that back into my equation and go, oh, that's the same number I had in design, so I've got a difference still, so it must be perhaps to do with fabric, and therefore I then would then go and do, in the world of academia, let's do the pathology, and I'll go, it's a word that nobody understands, let's call it diagnostics. So we go, okay, let's go and do some perhaps leak checkers, thermal bridges, so we can use thermal imagery, and we can look at how that building has got hot and cold spots, and just see whether it's and we can do some U value measurements in situ, and we can try and determine whether it was, did I build it wrong and miss some insulation out, or did I not, when I put that insulation in and I didn't do it correctly around the reveals around the windows or whatever, so I had some big thermal bridges in there, so they were causing greater heat losses than designed, because the installation may have been incorrect, or there may have been a change of spec and people have put something completely different in compared to the specification, and that performs slightly differently. So it leads you down a path of going, I don't know what's causing it, but I can now start to do some other tests and expose where the areas I now need to go and investigate. And that's exactly like if I go to a doctor today, they go, well, okay, we do a blood test, that'll tell me one thing. We're going to send you to, do something, and all it is, we're trying to follow that path and work out where the difference is being caused.
That's really interesting. That's a really great comparison, actually, with doctors. And is this where the under and over performance comes in as well? Because I wasn't quite clear on that. So underperformance is obviously where you're getting more heat loss. Overperformance, is that where it's too airtight and actually you don't get enough ventilation? Is that what you mean?
No, it could be a mixture of both. So your HTC is a number.
Yeah.
And it's inversely in your head. So a smaller number is a better performing building of a HTC, because it's the how much heat you're losing per square meter kind of thing. So a smaller number means it means it's performing better. Older buildings, remember that the first thing we're doing as design is that's a prediction. I'm predicting that wall is going to be of that U value. I'm predicting that I've got an air exchange rate of 3. So that's all in a model of maths. Yeah. When I then measure that air tightness, and that might be because some poor building, I didn't do overlapping of seams and plasterboards. I did a big hole and didn't patch it up afterwards. I will get a bigger infiltration loss as a consequence. So I might have said it was going to be 3, but it turns out to be 5 because of what we did on the site. Same as fabric wise is that there could be several different reasons. That the way we constructed it didn't quite go as per the way we were going to design it, and in new buildings there's a lot easier, and therefore that performance gap is probably not likely to be as big. And in fact, we were just talking to Saint-Gobain just now, and they're finding not a huge tolerance. And it was like 5% they had on one of them was 1%. So new build buildings seem to be performing quite well, as long as they've managed the site. But existing buildings, bearing in mind we're making some defaults. I'm going to your house, Ruth, and I'm going, it was built in the 1950s, and the building regulations said then that the all-U value would be X. And so that's the assumption I'm making. I don't actually know what it was because we don't have the specifications to your building of how it's been built. We don't know what other additional work you've done over the years to that building. So existing buildings are a lot harder to make that assessment. And RDSAP has been built over the years to cater for that. This comes back to this confidence thing again. They've sort of said, well, I sort of have to take some defaults, and I don't want to be worst case, and I don't want to be best case. I've got to find somewhere in the middle that gives me a good broad brush identification of every building in of our housing stock. So there's been a definition of what those U values should look like and what we think those air exchange rates will be like. So then when we do measure it, we do find that older buildings tend to overperform. So they're not as bad as we thought they were going to be.
Yeah.
But some of them will be because they've got into rack and ruin. I've done a hole for my new bathroom that's come along. They put new toilets in. They're not sealed it up properly. So they've got underperforming for lots of reasons because they've had remedial works and that hasn't been done properly. But so hopefully that explains a little bit why you're getting this.
Yeah, which explains also some of the results I've measured that actually with those heat pumps that they assumed what was it, like the 70% were assuming that they need a bigger one than they did because assumably because of these defaults.
Yes, exactly.
Yeah. Okay.
Exactly.
I just wanted to add that there is this sort of longer term, you've already alluded to it, the sort of the net zero by 2050 challenge. And whilst we're later to the party than we wanted to be as a country, we're nearly in the middle of the 2020s, and I think if we were being honest, we should have been doing much of this 10 years ago. But the challenge here is that we can start where we are today with relatively low numbers of renewable heating systems being installed, and we've got to go at this at some pace in the future. Plus there are other solutions that may or may not come online during that period of time. But if we start on the wrong path and we start installing larger or smaller heat pumps or heating systems, we end up in a situation where we'll carry on doing the same sort of thing and we'll miss our target. We'll either miss it because we need more energy than we thought we needed, or we'll miss it because our heating systems are just not running as efficiently as they can, and people are having to supplement with other fuel sources and a whole myriad of other unintended consequences. So it's so important that we start in the right direction. And yes, we can tweak it, but if we start completely on the wrong trajectory, we're in a world of pain to try and get to 2050.
Yeah, that's a really important point. And I guess that's also why it's right that it's within the Future Home Standard, because actually, if we're not getting it right, you want to check that you're at least getting it right as well with new homes from now, because, we don't want to be, as well as the huge retrofit task we've got, we don't want to be getting that wrong with new homes as well, do we?
100%. Absolutely.
Yeah. Okay. I'm curious about where the members are at in terms of this at this point. What are members saying about the use of measured energy performance in their work? What's the level of use? What's the level of maturity in that? Is the competency scheme there because of demand, or is it to try and push?
No, it's definitely a push rather than a pull. There's not a demand coming from them.
Yeah.
And our job has always been, I've just done the last Energy Matters article again on sort of MEP, because we're just keeping them aware. So we're raising awareness, the direction of travel. The whole conversation with government and certainly Eco4 has gone on for 2.5 years. And, you know, I've talked about it 2.5 years ago, going, oh, it's coming this winter, you know, and then the next winter comes by and the next winter. And so therefore, if that had come a lot sooner, I think we would have delivered a competency scheme a lot sooner as well. So, you know, the hard part is the scariness of I'm going to build the field of dreams and hope they're all going to come and play in it, you know, and therefore we're not trying to rush it, you know, because we're hoping that the other external sort of influences are in play to make people want to adopt it, you know. So
but the people that were doing it are probably going to be DEAs or air tightness testers that are already out in properties day to day. So we're hoping that they'll just see it as an extra thing they can do and offer.
The more we can get members being advocates and ambassadors, the better that will be for the market. You know, I recognise, you know, the position of where Elmhurst is in the marketplace. Whatever we do, we're not doing for Elmhurst, we're doing for the market. You know what I mean? We understand that. And as a consequence, our competitors will benefit from that as well. Got a powerful position, but we have with that position comes a huge responsibility. It's about making it right. And it's right because it's right for the market, and it's right for the government, and it's right for the whole net zero sort of like journey that people need to be going on. And therefore, you know, that's why we're spending the time to try and, you know, get it aligned in the proper way.
I think there is a tipping point as well, and I don't think we're a million miles away from it, Ruth, if I'm being honest. I think there's enough people talking about this, and there's an ever-growing understanding of what it is, why it is, and why it's, you know, what it can be applied to, and why that's important for the future. So I don't think we're a million miles away from it. So now is the time to be doing what we're doing. I did ask a pretty leading question at the Pepper conference. We had open polls throughout the day, and they opened up at relevant times. And one of the questions was, well, what do you think is the next thing we need to start to focus on in retrofit? And I said, and I put loads of options in there. One of which was the most popular was we need an enhanced retrofit assessor standard to all work to, and we need a retrofit policy or a strategy from government. And then third on the list, with I think it was about 15 to 20% of the vote, was we need to start doing measured energy performance. We need to start understanding the actual performance of our buildings. I also asked the same question around EPCs, and I said, what would you like to see in an enhanced EPC? And I did throw in about measured energy performance in there, and it also featured similarly high on the list of priorities. So it's happening. People are starting to think about it, and they're starting to prioritize it. And again, I can't see us being able to make really great decisions on our entire building stock, particularly the older, more variable building stock that's out there, and even the newer stuff, if we're being honest, because there's been such variation between one building and the next, that we need to adopt that better understanding, and we need to be able to measure it as well. Chris was talking about the performance gap. It exists. We don't understand it, and the only way to understand anything is to measure it and then measure the improvement.
I was actually going to say whether, and this moves on to a bit of a policy thing, because we've asked about including measured energy performance in retrofit assessments. Is that something that would, from a policy perspective, you'd want to see?
I'd like to see it, because that's what Eco4 is about, is, you know, we're making assumptions of how we think these buildings are going to, you know, perform after we've carried out a number of energy saving measures upon them, but are they actually performing to those? And therefore, am I making the right decisions? You know, and there is a return on investment element here. Verifirm did do it for, I think it was in Ireland. They did a review where they knew that this cavity fill was degrading, and there was a huge cost to removing it and replacing it, or removing it and putting an external wall on, or leaving it in place and doing some other measure. And so they actually wanted to understand the building performance so that they could sort of like, and they could do a trial one and work out where the costs were. And in the end, it was just better to leave it in, because even though it was not performing as best as you'd want, it was still performing to a higher standard. And the additional works that you could do for that cost, which could be new windows or new roof insulation, and perhaps some sort of like air tightness, sort of filling gaps and draft proofing, that kind of thing, was a bigger improvement than putting an external wall on, and the return on investment of that. So they could do more for their money and move a whole set of stock on that journey. You know what I mean? And I suppose that's the point, is that buildings are on a journey. And really, I'd love to see them every time they do some intervention in that building. You do a baseline, you carry out some intervention, you do another measurement, and so you get the journey of the improvement of this property.
Yeah, that aligns nicely with your call for EPCs, that every time you have a major something happens on a building, that you get a new EPC as well. So So in terms of how this changes practice, I think you've alluded to a little bit of that already. Is it just that in terms of how measured energy performance would change the practice of professionals, is it simply about that process? Does it remove the need for other areas of expertise? What does it do? And I say that not being presuming, I'm not adding any presumption into that question. It's just, does it remove anything? What does it do to practice?
No, I don't think it removes anything. My analogy will always be like air tests. So today we do an air test, and now we know how our building performs from an air test, and just adopted. Happens every day. We do it in retrofit, we do it in new build. I'd like to see the same for measured energy. You know what I mean? And as it happens more and more at scale, it becomes more competitive, and it gets built into other operations and activities on site. But what it does do is it gives you a better informed model of your housing stock. I mean, coming back to Andy's point earlier on, we've mapped our building stock in the UK, and therefore have put it on a net zero journey, saying if we do the grid, this will do this part. We do these eco off-gem sort of like measures, it will do this. If we start to measure every building, we might find they perform significantly better. So that flight path that we've got, we might suddenly think, hang on a minute, we've just dropped 1,000 feet. Do you know what I mean? We did, without having done anything, but just having a better understanding of what our stock really is. And then that gives you a more improved about, well, what is it now that we need to put the focus on? Is it accelerating grid decarbonisation? Is it something else? Is it about having, more about in time of use tariffs rather than it is about the asset? The thing will be, as we make our buildings perform better, the space heating requirements becomes a lesser aspect. Then you get the hot water requirements. So then there'll be a whole focus about hot water. Then there will be a whole focus about what can I generate in my own home, and how do I feed that back into the grid, or make that fit in a network that self-satisfy. But then it will be operationally, our energy is becoming less and less. I'm now worried about my embodied carbon. So hang on a minute, I can't just have knocking down Marks and Spencer's on Oxford Street anymore. I want to reuse that building. Am I building my buildings in a way so that they're not capturing carbon and being destroyed and being released again? Or am I putting small amounts of carbon into my building? So it will open up another world of other things to focus in.
Yeah, that's a nice way of putting it. Yeah. We've talked a lot about this already in terms of retrofit and carbon net zero, moving on to that policy side. In terms of how measured energy performance is important in the retrofit challenge, we know that it is because we're looking at more accurate picture of what the energy performance of older existing dwellings is. But if you sort of had to say one thing as a plea for measured energy performance for retrofit, what would that be in terms of its role there?
Well, I see it as a bit of a measurement and verification piece.
Yeah.
So I've got a design intent. Have I got what I thought I was going to do? You know what I mean? So, we are spending money. We're spending a lot of money in retrofit, especially on government funded retrofit. But equally, if I was a homeowner, you and I going to get a mortgage and wanting to do some work, did I get the intended outcomes?
Yeah.
That's what it's good for. And that fits into the whole pass. At the moment, there's just a tick box. Did you do the installation? Tick, yes. Did you upgrade the efficiency of the heating system? Yeah. But no one's really measuring it afterwards and going, did I actually achieve what I said I was going to achieve? I didn't do a pre and a post and go, yes, I got what I bought. My gap is closed. So I see it as a validation of that.
Talking about validation, obviously RDSAP, SAP, any model really has assumptive values built in with it, and is a particularly useful thing to do when you're trying to get to an end point, i.e. you need to get an EPC or a report to do something, and I can't have a U value calculated. I don't have enough information or enough data. Measuring things, because we haven't done it en masse, a lot of these assumptions are best guesses, based around a sample size that's particularly small or maybe geographically specific or not geographically diverse. This is an opportunity to really, really upsize that data set and really amend or make those assumptions far more accurate. So we could all of a sudden have an assumption for, I don't know, one particular area of the country, or a better default U value for RDSAP for an age band. That would make things far more powerful. So we've got this constant feedback loop where we are able to adjust and improve our assumptions as we go forward. That means our models will be better. So, a better model can be applied more confidently and be used in more scenarios. And then we always have that ability to measure where we think it's necessary or whether we want to confirm what we've done. And I think that duality is something that either has not been appreciated and needs to be, or really needs to be part of that whole retrofit piece. And it's just it's not been done yet. And that's the whole monitoring and evaluation piece that's built into PAS 2035.
Well, it feeds into policy. Government policy makers are making decisions about our housing stock and where they want to spend their money and the direction of travel and what's their major focus, etc., based on, I don't know, 10,000 home BRE housing report for 2023 or something, and that's a sample set. As we start to put more information back into that, government can make a more informed idea of their policy. Is the policy working, and is it giving you that return, and are they putting the focus in the right place?
Yeah. And that would, like you said, I think you made that point. In fact, I think you both made that point, that actually this accuracy, it might tell us that we're in a different place on our carbon net zero journey. So, it has the power to actually put us the marker in the right place, I suppose, doesn't it, in terms of our housing stock? I think we've talked a bit about how it can deliver new buildings to carbon net zero ready standards, because obviously, in terms of that performance gap and the updates to the building regulations that the Future Home Standard will bring. So I sort of feel that we're fairly, got a fair idea of that. But was there anything that you wanted to add there on how measured energy performance can support those, making sure that we are meeting the future standards?
Only thing I would say there is that if I was in a factory environment, I have lots of checks and balances, in the production of my product that comes out, that it's been quality controlled and quality checked. In the construction industry, that's a lot more difficult, but that doesn't mean we can't do it. And so particularly when I'm making at mass developments with different sort of like labour gangs and all those on site, it does provide that quality check scenario. So that builders will want to then we go, well, actually, yeah, I do deliver a quality home stamped by whatever, Elmhurst stamp of approval, whatever, if I'm putting on my commercial hat. So, so from a new build point of view, people then can have confidence in the homes that they're buying are actually meeting what they're expecting. And planners are, when they're putting pressures on developers to create new developments with low carbon, with low embodied, with the biodiversity, are they getting what they want? So we're working with a developer today doing that whole building performance evaluation piece over 3. That's therefore then you've got a planning council going, yeah, I understand how that went in. I feel good about it, and we will make sure that's our specifications for future developments need to meet it.
Yeah, that's a really good point too, actually, about how it feeds into planning departments. We've covered about how it could be a tool to support government policy. I think you touched upon that point specifically, Andy. I feel like we've talked about it, we've measured as well in terms of that uptake of heat pumps and the fact that what it does there. I wanted to ask just a little bit now with the time that we've got left. Do you see measured energy performance being included in regulations, and how fast and how far can we go with that?
Chris and I probably end up saying very similar things, and I'm going to step in before Chris on this one. Yes, they have to. I think we have to see some regulation here in appropriate ways, whether that's from a retrofit or a new build perspective, and probably both, because there'll be people out there who will do this. There will be builders, there will be installers, there will be coordinators who will prioritize this and maybe incentivized to do so through things like pay for performance. But if you don't have the regulation there, then there will be those that will avoid doing it, won't do it, have no interest in doing it, and they will just carry on in the same vein. And then you obviously need to have a way of checking and enforcing it. There's no point in the regulation without the enforcement side of things. I do see it in a very similar way to the way that it rolled out something like air pressure testing, which came out in 2002, wasn't mandated, was then mandated for certain buildings and a sort of a sampling process. And maybe that's the way to do it here. I think it's those that will benefit from it will see that benefit straight away, and there will be those early adopters and those repeat users, and then you've got to bring everybody else up along for the journey. I do see PAS 2035 as being a big part of it. It is a standard. It is a minimum standard. It's being applied by government through Trustmark into Eco and to other funding streams, and they really need to get onto that measurement, evaluation and monitoring aspect as soon as possible, because it has been ignored in sort of preference of getting everything else working correctly. I think there is a worry that there's a cost associated with it, but I think we've already discussed the virtues of it and actually the likely savings to doing it. So I think we ought to try and the conversation doesn't need to just be about the operating cost of doing PAS. It needs to be the longer term view as well.
Yeah, that's a good point about moving it in with, because Eco, I mean, there have been criticisms of that, and there's the same criticism of GBIS that it's single measure. So you're saying then that actually this would then, by moving measured energy performance into those and using them as part of the schemes, you then solve some of the issues that might be currently happening, that around just single measure energy efficiency improvements.
I mean, a whole house as well. I mean, and anything in between. I mean, the challenge we have at the moment is we have a desire to move to this whole house retrofit standard and process, and the funding doesn't quite relate to that, or doesn't always equate to that, and it is down to who's got the funding, the property, the building, the occupier, what can be done in what order, how quickly can they do everything in the 6 months typically that a project is required to be completed by. It's a test bed, it's a launching mechanism for getting something like PAS. into being. It's also the government's testbed and launching mechanism for pay for performance. So, that's what we have to play with. But I think for other things, particularly new build, the regulation, we've seen it come in with, as I say, air testing. I would like to see something similar come in for measured energy performance. We need to cut down on the performance gap. We need to understand the actual performance of our buildings. And we need to use it as a way of saying something's wrong here. We need to investigate further and put it right before someone moves in there, lives in there, and then starts to suffer as a result of, insulation that's not present, or a defect in some way, or air leakage, unintended air infiltration, etc., etc. Thank you so much for listening to that special edition of the podcast. The MEP training is available on demand from the Elmhurst website, so please check it out. We're currently working on season 2, and we're looking forward to speaking about a number of exciting topics and things that are happening in our industry. So stay tuned and please subscribe, and you'll get your podcast delivered as soon as it's available. Thank you very much.
Thank you for listening to Energy Talks. Don't forget to subscribe and send your questions and feedback to marketing@elmhurstenergy.co.uk.